deep sort of on Shiny apps mainly, but also like covering some of the work that we've been doing, like as part of our work at the Biometry Hub, sort of deploying Shiny apps that we use in our research and for data science and data analysis purposes. So let's dive in. So when I say Shiny, of course, I mean like R and Shiny. So R is a popular programming language for statistics and data analysis. Many of you have probably heard of it. Most of you, or many of you probably use it. So what Shiny is it's sort of a web application framework built entirely out of R code. So if you can code in R, then making the leap to coding in Shiny is less hard than making the leap to coding in something else, for instance. And it essentially allows you to wrap your R code that does your statistical analysis, your data analysis and all of that into interactive user-friendly interfaces or apps that you can deploy on like online or etc. It allows you to sort of visualize and show off your data or analyze your data. There's many uses for these, which we'll see in this talk. So yeah, as I've said there, R and Shiny have really so they've come into vogue in the last decade, and they've really revolutionized the way that we as like data scientists and researchers can analyze and visualize our data. It's made the process of doing that much easier than it has been in the past. And it's almost sort of conducive to disseminating our research to the wider community, and it does bridge some of the gaps between like us doing the research and the end users and clients that we eventually want to be able to benefit from that research. So that's me talking about it. That probably doesn't mean a lot to anyone. So let's actually see an example of one of these things. So here's a topical example, right? There's a pandemic going on now or something, and someone's built a COVID-19 tracker for it. And they've done it entirely in Shiny and R. So that was developed by Dr. Edward Parker and the London School of Hygiene and Tropical Medicine. So I'll just cue this window for a second and bounce over to where I've prepared it earlier. And this will hopefully reconnect. Possibly. Oh no, hang on. There we go. So this is the app, right? So this is an example of a Shiny app. So as we've seen, like it's a COVID tracker. So what it does is in the background, it's downloading all of the new case data. It's actually getting that from Johns Hopkins. They're the ones that are doing a good job of tracking it. And as you can see, it's like a cool sort of dashboard visualization. So rather than like the people that wrote this going, right, let's just put everything in a table and put it on some foreboding website somewhere and just say, if you want to know what the cases are, go and look at a bunch of numbers. Here you've got like an interactive map. You can zoom in. I'm on a laptop, so it's a little difficult to scroll. But yeah, you can zoom into like whatever country you want, hover over, like it immediately gives you the number of confirmed cases, 7-day average, deaths, cases per million, sort of visualizing the data, right? You can see these graphs up in the corner, can change mapping dates, like a whole bunch of widgets that allows like, so you don't even need a statistics background to be able to use this thing, right? So it's got a mapper, it's got region plots. So what's cool about these, right, is that you can select exactly what visualizations you want, exactly how you want it to look, and on the fly, it just regenerates that stuff for you. So you can do just the new cases or the cumulative logged cases if you want, which is sometimes useful if there's a lot. So it's to some extent putting the power to like do data analysis tasks into everyone's hands. Like, so rather than disseminating research being, here's some figures, we've done the analysis, just trust us. It actually lets your end users like get a feel for the data and explore it for themselves. So this is actually a pretty good example of an app, really. I think they do SARS as well as COVID. All sorts of toys that like the users can play with. Like, so this is online, right? Like you can go to this same link, load up the exact same thing, truly accessible. So yeah, that's as I was saying, like, so through the Shiny app, your end users can directly get a feel for the data. Like they can have a play with it. They can explore their own tailored visualizations. It's all cool. Like, and it's a very impressive and stylish way to actually disseminate our research outputs. So we'll use that as the motivating example going forward for what a Shiny app is. So a question is, why Shiny, perhaps? So you're probably thinking in the audience, like Shiny's not the first example of something like this coming along, right? Like there have been data visualizations for almost as long as there's been data. What makes Shiny good is its ease of use, I would argue. Particularly for the people like us that are sort of analyzing and doing the statistics on the data. We're probably not the same group of people that are good at doing visualizations and good at using, you know, HTML5, CSS, JavaScript to like draw pretty graphs and make visualizations. So traditionally, you would have had to sort of have a middleman there. Like if you wanted to do a pretty visualization, like for an end user or like a tool that they can play with to explore data, you'd have to call in a programmer and get someone to actually build this thing, someone who knew how to build graphical user interfaces and all of that. So Shiny cuts out that middleman, like puts everything in your hands, like as the person who's using R to code it. And in that way, it bridges the gap like between researchers and the people that they actually want to talk to, like, and disseminate their research results too. So on our side, for us data scientists and researchers, there's no need to learn complicated web frameworks or JavaScript libraries, as I was saying before. You don't need that programmer to bridge the gap between what you want to say and actually coding it up and getting like a pretty visualization to say it. You can do all of this in R, like a language that you can use for data analysis. And it enables the impressive and accessible presentation of research and data analysis tools. So like as we've saw with that app, you can deploy this stuff online. It looks just like a website, like that a user can just go to and click buttons and drag boxes and look at their data. So that's from our end, the benefit. For the end user, it's even better, right? Like they want to be part of the data analysis process, ideally as early in the data science process as possible, right? Because often, as we've found out in our work at the Biometry Hub, the end user is the people that have the awesome domain-specific knowledge that allows them to actually look at the data through a better lens, for lack of a better word. So having them involved in the data analysis process, period, but also as early as possible is a good thing. So in their case, they don't have to learn R. They don't have to learn sophisticated statistical techniques. It's all coded in the background in Shiny. They have a toy that they can use to play with and explore their data. They don't have to worry about too much about how it works. And in that way, it enables collaboration and participation in the data analysis process. Like, so there's collaboration there from the start. It's not just sort of giving everything to a statistician and then them doing some magic and giving you back results. They can be involved like throughout the entire process. So these Shiny apps are sort of useful, and at the Biometry Hub, we've sort of gotten into a bit of a habit of making them for as many things as we can. So here's another example of one that's actually in-house and is in preparation currently. That's called Visual Designer. So I'll show it as another like sort of impressive, I guess, if you like, example of the things that you can do with these Shiny apps and visualizations. And this one, it allows users to interactively generate design of experiments, or experimental designs rather. So we'll actually see that here. Yep. So for instance, if they wanted to generate a randomized complete block design, which is a typical agricultural design, they can specify the number of blocks, number of columns per block. You can see that they get immediate sort of visual output. That one doesn't look too nice. Let's make it columns. They can specify the treatments that they want. Treatment prefix we'll keep as A. It's giving them feedback, like so for our design, we need 16 treatments in each of those blocks. The default was 12, so we need 4 more. So we just change that to 16. Everything's good. Generate the design. There it is. So it's easy as, and they can download that as an image or, importantly, a CSV. So if I click this, is that going to open on this same screen, hopefully? Yeah. So that's exactly the sort of design that you would hand to like a sampler or a researcher or a statistician, and they can use this. Like, and this is exactly the spreadsheet version of that. So that's exactly encoded design in a spreadsheet that they can use to go out and actually collect their data. So they just add columns for the treatments or observations that they make, and it's all good. So that's Visual Designer. So it's another example of an app that's an impressive data analysis tool in its own right. Like, so it's not even just visualizing, it's actually empowering the process of doing the research, like from the outset. And importantly, like I'm not actually a statistician, like I'm surrounded by them all day, right? But so it's good for me because I have no idea like what some of these designs are, maybe, or I mean, I do have an idea, but I don't need to know the specifics of how to go about generating that design. I just click a few buttons, it gets the design, and everything's good. So it's actually encoded the statistical technique of doing that experimental design, and the user doesn't need to worry about it. So here's another example of an app that we've made. This one was actually made by Sam, a co-worker and friend of mine. So this is further down the track of the data analysis process. So whereas the one before was how do we actually do the experiment and generate like best practice experimental designs to capture the data. This one you would use, say, if you were like further along in the analysis task, you've got the data, you want to have a look at it, you want to start making some plots, generating some reports that you can show people. So we'll bring this one up as well. This is going to do that thing again where I need to make a new tab, isn't it? I've learnt from last time. Yep. There we go. So, I mean, you'll notice immediately with this one is that it's, if it's going to load, it's visually impressive. Sam's put a lot of polish onto this. So we'll use the built-in iris data, but you can also load data. I just don't have any on hand at the moment, and technical issues will make this presentation too long. But for instance, so it's using an inbuilt data set of flowers. So it automatically tabulates that. So we can automatically see that. We can use the search to filter. So it's just good for giving you a sort of bird's eye view of what data you've got. You can start plotting things. So if we wanted to plot petal length by width and notice some clustering perhaps. No, that's probably not too much of a useful color. Let's color by species. There we go. Can change the point size. So keep in mind that the end user is the one that can do all this. Like generating the plots is now firmly in the hands of like the person who's actually interested in doing the plotting. And then we can tabulate the data. You can change values if you want. For instance, it's all very cool. Did that change anything? Yeah, a little bit. And then, so you can generate a report. For instance, open. Yeah, so it's just a report, not too flashy, but the sort of thing that you would show someone like as sort of a brief overview of the data. So it includes all the data, the plotting window. Perhaps I made the points a little too large. That's all good. And also the model. So it's actually fitting just a basic linear model and getting some estimates for the coefficients of the line of best fit looks like. And that's good. So what this also demonstrates though is that using the Shiny app, you can also automate a lot of this stuff. So we'll go back to the app. And then so like we use the inbuilt data set, but you don't need to. So you can upload a CSV of whatever you want and do the same process. And that's cool in that regard. All right. So one thing I do want to sort of highlight during this, it's a bit of an implicit point, but I think it's an important point, is in data and science and statistics, it's really easy to get the wrong conclusions if our analysis is wrong. So we do need to be careful with our methodology, and flaws in our process do multiply, and we can lead to completely incorrect, unfounded conclusions. But what we do through the Shiny app implicitly by documenting like our analysis approach, right? Like we saw that in Sam's app earlier, generating the report, everything is listed there. Like all of the plots are reproducible. The analysis is properly documented, like the actual analysis is properly documented, not what we've typed up in the PDF was the analysis. And it's cool in that way because it encodes our methodology. So it increases confidence that our statistical data science methods are correct because they're there for everyone to see. And if they're not, then we quickly get bombarded with people telling us that they're not. So that's also an impressive sort of byproduct of these Shiny apps, is that by disseminating research outputs through them, we're actually documenting our analysis workflow, which is, I think, a good point and one that's not immediately obvious from the outset. So here's another example of a sort of more impressive Shiny app. So it's not just about data visualization and reporting. You can sort of anchor some impressive computation to these things and do some really awesome things. So here's an app that's also developed by us and sort of in preparation. What it does is it uses a neural network to scan an image like of a field taken by a drone and automatically counts plants. So it's automated sampling in some regard. You give it an image of, for instance, faba bean seedlings in a field, and then the trained neural network scans the entire image. You can divide it up into rows and columns if you're interested in sort of a estimate of spatial emergence. So it counts each of the plants and generates spreadsheets and reports on the emergence and other ancillary sort of statistics. So we'll see that example here. We're working through the examples, don't worry. F5, yep. So for instance, this is the app. It isn't deployed online anywhere, but this is what it would look like if it was deployed. We'll get to why it's not deployed in a second, actually, because that's the second part of the talk. So you can upload an image. We've just got this one that I prepared earlier. We can draw our grid. Let's make it 2 columns, 3 rows, for instance. And then we click detect plants, and then it'll go through, scan each of the little sub images and highlight where it thinks a plant is. So, I mean, it could be quicker. These are big images though, and there's always, like, it's hefty computation. It's not perfect, but sure beats going out in the field and actually doing it ourselves, right? Like, at the end of the day. So, yeah, it'll go through, it'll count all of the plants that it thinks are plants. It might miss this one, yeah. So there's room for improvement. Like, so in the back end, what we've actually done is we've trained a neural network, and we can keep training that neural network to increase the true positive rate and get rid of the false positive or false negative rate. So when it's scanned that, you can download the counts to CSV, or you can flip over to here where it tabulates the data. We can plot histograms, summaries, so if we know what the size of the area was, the sowing rate, the seed weight, all of those things. It gives you actually quantitative values that you can use for your analysis. Or heat map to show emergence, for instance. So this one reckons it's sort of lopsided on the right-hand side of the plot, which may be true. Yeah, at a glance, it does look like there's more plants on the right-hand side of that than there is on the left. False negatives notwithstanding, but yeah, so the point is that it's a tool that you can use to sort of analyze your data. So, and it's all in Shiny, like this is Shiny and it's all good. So back here. Yeah. So we get to the question of deployment. I've been using that word a lot. What does it actually mean? So once we've actually designed the app and we've got it working, like we've tested it locally and it seems like everything's good and we want to expose it to the big bad world, the next step is to deploy it so that others can actually access it online. For simple use cases, which was the case with the COVID app and the automatic report generating one, so simple is sort of relative. You can deploy it for free on the shinyapps.io platform. So do I actually have this as a tab? Hopefully, yep. So I'll just refresh just in case. So this is what that looks like, right? So at the moment, I've just got one sort of deployed app that I was doing for something. I wonder if, yeah, so it's not online anymore, but so you can bring it online. It keeps track of all your app deployments. The important part of that is, since it's free and of course you get what you pay for, there are limits to the platform. So for instance, in this case, while deploying them on Shiny apps offers reasonable hosting with minimal fuss, the second you've got a not so simple use case, which in our experience is all the time, it quickly becomes prohibitive, the limitations on the free tier. And arguably, I've said there's some of the paid tiers, just in case you were wondering if I was sponsored by shinyapps.io. I hope not, because I would have just been fired for saying that. So what we've found in our work developing apps for a lot of the projects that we've been doing lately in the Biometry Hub is the moment you've got a heavy computational workload or you're sifting through a lot of data, the limits of the Shiny apps.io platform prevent you from doing that. So why is this pertinent? Well, big data, right? Like a lot of us are looking at sort of big data sets, like not like megabytes in size, but perhaps gigabytes in size. The moment you're up to a gigabyte, Shiny Apps is out unless you want to pay money for one of their paid tiers. And here's why. So while it is free for the free tier, and you do get easy setup and deployment, like it's literally just a couple of commands at the R console, and you do get layered host side security, which arguably is important because if you're doing self-hosting, to some extent, you need to start worrying about security. You've exposed your server to the wide open web, and there are some bad people on the web, and they want to get into your stuff. So you've got to always keep that in mind. Whereas here with Shiny Apps, you don't have to. So those are the pros of a Shiny Apps deployment. The serious cons, so you have 5 apps simultaneously and 25 active hours per month. So what an active hour is any time a user anywhere in the world is communicating with the Shiny Apps server to access your app counts as time in those 25 active hours per month. So you can imagine if you're using Shiny to do any sort of a serious workload, you very quickly burn through those hours and you've only got 5 of them. And all 5 of them have to sort of divvy up that however they can and per month. So if you hit that 25 threshold, that's it. No one can access your apps again until it rolls over. Even with those sort of time constraints, you have software like resource constraints as well. Your entire Shiny app session is limited, at least on the free tier, to 1 gigabyte. So that 1 gigabyte has to include the app itself, has to include all of the data that your app is using, all of the data that your user would upload, and to some extent, all of the random access memory that it would do to do any number crunching. On top of that, there's a 30 megabyte data upload hard limit, which precludes, for instance, we saw with that, the neural network app that I showed you earlier, those photos would then have to be less than or equal to 30 megabytes, or they can't even be uploaded for the neural network scan, which gets very prohibitive. I know recently in some of the projects, we've been looking at files that are averaging 90 to 100 megabytes for the field. So we just can't even use that app with them yet, unless we deploy it ourselves, which I'll get to in a second. Arguably, I included this as a con. Most people probably wouldn't care, but there is limited ability to control library versions and operating system level libraries. In practice, this doesn't matter a lot because actually the people that run the shinyapps.io platform are very receptive to you emailing them and saying, hey, my app needs this library. Can you spin up an instance that includes this operating system library installed so I don't have to worry about it? Often they're very eager to say yes. But sometimes you want that control, like you want the ability to control versions of your library that end up being used by your app. You don't want it to be working today, and then because a package updated in the background and your code doesn't work anymore, users can't use your app anymore. Whereas if you'd frozen the package versions, they'd be able to. But sometimes you want to avoid those situations. So you want more control over the ability to control whether you update, when you update, what gets updated, what gets installed, those sorts of things. So particularly the first 2, I would argue, are quite stringent resource limits. For some of the more complex apps, and we'll see an example of one in a second, and the more complex use cases, Shiny Apps isn't going to fly. And you look at the paid tiers and they're not particularly competitive. And so the idea of setting up a server ourselves and running the Shiny app, doing all of the hard work of maintaining and administrating the server actually starts to look reasonable by comparison. So we'll get to our main case study. So this is the etiella degree day model app. So what it does is it uses a model developed by Sardi called the degree day model to predict etiella moth outbreaks in South Australia. So we developed that in collaboration with Dr. Kim Perry and Sardi. And by collaboration, I mean like they did all of the work of the degree day model and sort of what they wanted it to look like, and we just sort of packaged it up in a Shiny form and made it look pretty and deployed it. That's still a team effort, I would say. So I will bounce to this app. Yep. I've got too many tabs open. And this one is going to do that thing where it's not going to reload. So I'll paste and enter. So it's actually at etielamodel.app right now. So you can visit it like mid-talk while I'm talking now if you wanted to. And it's a cool little app. So you can use current location to get where I am, like I'm at weight. But so for a grower who's worried about their crops being or their lentil crops being infested by etiella moths, and maybe they're in the north of Australia, they can input their coordinates, update, and it tells them the degree days that have accumulated. It's got a graph here that compares it to previous years, and also tells them that they need to be monitoring now because once it's hit this 351 threshold, that's where the model predicts that the peak moth flights have commenced. So they need to be actually out doing things and making sure that their crops aren't being destroyed. A little further down in South Australia, like where the degree days haven't quite hit that threshold yet. This one's up at the 301, so they need to have started monitoring now. A little further down where it's a little cooler. Yeah, so we're not in the danger zone yet. We'll start monitoring when it hits 300. And during the lead up, which is, I suspect, why Kim included all of the previous years of data, you can sort of see that, for instance, here in this location that I've selected at random, the people here would probably be looking at the previous years of data. Maybe they have 2018 as well, just to check. And they go, yeah, it looks to me that it hits around the 300 threshold at roughly the first week of September. So it's not quite the first week of September yet, but we're getting ready to actually start monitoring crops. So it's useful to the end user as a tool in that regard. So it's got an instructions page and a credits page. That's a PDF that they can download that tells them how to monitor and spray for these moths. But overall, it's a useful tool, right? And I want to stress it's a simple tool, at least for the end user. There's not too much that they need to think about. They can just click on the map, update coordinates, look at the graph, read. It's cool in that regard. So yeah, we've just sort of gone through the app, but the features and stressing that it's a simple app, at least on the surface. So it runs the Sardi degree day model to gauge the etiella moth activity. Users can input their GPS coordinates, whether that be by typing them in manually, clicking on the map, or clicking the Get My Coordinates button. They get immediate feedback in terms of the graphs and the tables. And the thing at the top here that says how many degree days have accumulated and what their action should be if they don't want their crops ruined, perhaps. It's immediate feedback for their local area. And then as we saw, there's previous year's data also available for comparison, which is particularly useful during the lead up, as I showed. August, September, you can see how on track you are. With some sort of discrepancies, it generally follows a trend. For instance, all of these sort of hit probably in the first week. So it lets you eyeball to some extent when you need to start monitoring. So that's the front end of this app. What's the magic that goes in the back that actually makes all that happen that the user has no idea about, I should stress. So on the hidden server side, the app's sitting atop an Ubuntu Linux virtual machine. It's on a Google Cloud Compute platform. So it's basically a virtual computer that's acting as a server. So when the user goes to the website, it returns the app and they can use that. So we were using weather data to compute the degree days for the model. That weather data has to be downloaded from a Bureau of Meteorology data subscription at regular intervals. It has to be integrated into the existing database of data that underpins the app, and it has to be done in a way that if a user happens to magically be using the app at the exact second that the database is being updated, the user doesn't get hit with cryptic errors about sort of file read errors or any of that. So it's a bit of a non-trivial problem there. But that's all handled by the server. The user doesn't have to worry about it, doesn't have to know that it tries to integrate any new data that it finds on a 2-hour interval. Like, they're all details. So that weather data is interesting. So the point data is stored on the server at a 0.01 latitude longitude resolution for the entirety of Australia. So we saw in that app that the user can just click and then it automatically immediately recomputes everything and draws the graphs. In reality, what that entails is that we have to have a massive amount of data on hand at a moment's notice because we can't predict where the user is going to click. But when they've specified a latitude and a longitude, we have to immediately be able to go and grab that temperature data, like the maximum and minimum temperature. So it turns out that's a massive 5 GB file that gets probed every time there's an update in the app. So immediately, shinyapps.io is ruled out, right? Like, we can't store 5 GB worth of data when we're given 1 GB for the entire thing. So that was the first issue. Issue-ish. Also, I think we saw when I clicked first to grab the get current coordinates, it magically knows where I am. So there's routines for geolocating, like based on IP addresses and GPS coordinates if they're using a phone. Those have to be coded and those are on the server, like, so the user doesn't have to worry about too much about how that works. And it's over HTTPS, so it's secure, less hackable, if you believe the hype. And that has to be controlled by us. Like, so whereas for shinyapps.io, we get given that out of the box, like they handle the security on their end. To some extent, we've had to handle a bit of the security on our end. So I've set up an Nginx reverse proxy that just filters all of the requests from users through the secure HTTP protocol. But again, like, so that the end user doesn't need to worry about any of those details. So here's a funny story. Sam and I, so Sam Rogers, the guy I mentioned before, worked with Kim to develop what's essentially the crux of this current iteration of the etiella model back in September 2020. So that entailed doing the code, configuring the server, doing the Shiny app, deploying it on a Google Compute virtual machine on the cloud. And then everything worked fine, and that was all good and sort of hunky-dory, right? Then, as it turns out, we learned the hard way that when you stop paying the upkeep bill because, like, it's finished, like, we only want the app live during August and September, so we're not paying Google to just keep it alive forever. Google just deletes everything server-side, which is kind of frustrating. I think Sam and I were both expecting that at the very least, I mean, you wouldn't expect them to keep it up. You would expect them to keep, like, the image of the virtual machine around, like, sort of Google Drive style, like it's just like bytes on their server. So it turns out we couldn't just immediately bring that back up when Kim wanted us to this year. So we're still professionals, right? So we backed up and version control all of the code and assets. So it wasn't too difficult to spin up a new one. But all of the ad hoc tweets that mainly Sam was doing to the server to get it working, like the things that you wouldn't even think to write down because they're so ad hoc that you're never going to need to remember it, presumably, because you don't foresee that Google's going to delete your entire server. All of those things we had to sort of re-engineer from scratch, which we did. But this time we brought in Docker. So what Docker is, it's sort of a software containerization solution that's getting into vogue lately. Like a lot of businesses use it. A lot of researchers are starting to use it. So more on that point in a sec. So what is a container? So what it does is rather than considering the Shiny app, just the code and all of the assets that the Shiny app uses, it considers the container that it's going to deploy to be also the underlying operating system, all of the configurations for the server, all of the software libraries in one massive package. And then so what it does there actually is essentially outlines a procedure for how to reconstruct almost byte perfect, almost, but like basically for our purposes, a byte perfect reconstruction of the final server, including all of the system configurations. They're all encoded. So people in the software industry have been using this for ages. They've called it DevOps. So rather than just programming, sort of the meta programming of like coding exactly what libraries get used, what system architecture you're on, etc., etc. So the bottom line of all of that stuff is that you end up reproducing the exact same system configuration on any computer. Now, I've linked an article there that was interesting. Boa Tigger, who actually runs some of the Docker instances for R and R Studio, he argues convincingly, I might add, that this DevOps style of like byte equivalent reproducibility should actually be the standard for all of our modern research reporting. So he goes in his article saying like, how many researchers have you ever spoken to or like been in collaboration with that have said, oh yeah, I saw your code was included with the article, but when I tried to run it on my machine, I got an error. So Docker is designed to sort of kill that problem dead at the outset. So rather than just giving code, we give the container that contains the entire snapshot of the system that the researcher was using when they were doing the research. So ideally, but in practice, like mostly, you end up with exactly the equivalent system to the researcher when you use their Docker image. So you don't get any errors about incompatible libraries or missing files or any of that. Whatever they were doing while they were doing the computational research is available to you in the container. So he argues that we should be doing that, or at the very least that Docker should set sort of a gold standard for reproducibility of computational research and code and all of that. So just about done, I think. How am I going for time? Hopefully good. So here's the unseen technical stack that actually underpins the etiella model app. So all they see is they go to their computer on a browser, open etiella model app, and everything just magically works, right? On the back end, so we've got the Google Cloud platform that's basically emulating a virtual computer that's emulating a server. So we've got our Docker container. It contains our Nginx reverse proxy and the Shiny server, which both work to actually deliver the app to the user that connects to it. And we've got all of our sort of ancillary details sort of stuff. Like, so we've got to get the SSL certificates. We've got some scripts that do the downloading like every 2 hours from the Bureau of Meteorology's data subscription. Got a persistent disk because we want that database of weather data to be available for other uses as well. So all of the details that go into producing that sort of impressive and simple and nifty app that users can just navigate to on the internet and don't have to worry about it. So that's the DIY approach to doing the app deployment. So there is shinyapps.io, but there are also ways to sort of spin up our own for when the need arises, as it often does. So actually, that's almost my entire talk. So hopefully it's not too short. But so concluding thoughts. So as I mentioned earlier, Shiny bridges the gap between researchers and our community of end users. So it allows us to disseminate our research outputs. Crucially, it also allows us to get them involved in the data analysis and data science process. Why this is good is that as collaborators, they're often the ones that might not have the statistical knowledge, might not have the programming knowledge that lets them spin up the app, but they're the ones that have the important domain-specific knowledge, very important domain-specific knowledge that actually understands how to semantically make sense of the numbers that we're crunching. So getting them involved in the research effort at the early stage is always a good thing. So we saw that Shiny apps provide a relatively easy way to develop the data science tools and visualization and to some extent automated reporting for our data sets, like all of the tasks that we would want to be doing in data science, statistics and all of that. And in Shiny apps, it's an impressive package that allows us to wrap it up and share and all of that. So the Shiny apps free tier hosting, arguably their paid tier as well, I would include here, sometimes has drawbacks. Like it often suffices for simple app deployments. In our experience, the moment you've found anything that requires a hefty amount of data or like some sort of custom analysis or computation, those shinyapps.io hosting won't quite suffice for your purposes or our purposes. But where necessary, like as we saw with the example of Kim's app with the etiella moth degree day model, where necessary, we can extend the underlying architecture and set up a customized deployment for powerhouse sort of heavy data resource intensive Shiny apps where we need it. It does involve us spinning up our own server, so there are other issues, but we can do it. And people can do it, I guess. So that's the talk, I guess. Thanks for listening to me prattle on for almost an hour, I guess. Any questions or?
Thank you very much, Russell. That was very interesting and all the potential tools for our researchers to use. If you do have any questions, can you please type them in the Q&A box and I will read them out. So if you've got any, if we can get them typed into the Q&A, that would be great. Yep, okay. Okay, and we've got a thank you from Mario for a great talk for you, Russell.
Cheers, Mario.
Yep. Do we have any questions? Otherwise, I would like to thank you very much, Russell, for a really interesting talk, and it's probably a lot for the researchers to think about and their potential applications that they can contact you for. So
no worries.
Thank you very much for presenting.
Thank you.
Okay. Thank you, everyone, and hopefully we will have another webinar next Thursday at and they'll be shifting to 10 o'clock from next week as well. Okay, hang on. We do have a late question from Kelly Hill. Do you think it is achievable for researchers who use R to make their own Shiny apps? And do you have any workshops?
Yes, we do. That's actually a great question because it allows me to shill. So as like part of our biometry hub, like we absolutely do have like workshops and stuff that we like have for like learning Shiny, learning R, and that sort of thing. So actually, I'll cycle back to the start. So yeah, definitely get in contact with us. What was I looking for? Doesn't matter. Definitely get in contact with us because we do run workshops and stuff. Sam runs those actually. He's a great teacher in that regard. But also, like, so your question was, can people who are familiar with R use Shiny? And the answer is absolutely yes. That's partly why it's cool, is its ease of use. If you've been using R, then there's almost not too much to learn to use Shiny, which is what separates it from complicated web frameworks and JavaScript libraries and CSS and all of that stuff. Like rather than having to worry about all of those details, if you know how to code in R, there are like tons of resources, and coding Shiny apps is straightforward.
Okay, and I do have a couple of questions. Murray, I also had a question of how do you update the temperature?
How do we?
Yes, I'm not sure on what terms. I assume for the etiella app, maybe.
What was the question? Sorry, how do we?
How do you update temperature?
Update temperature.
Yeah.
Yep. So that perhaps was the etiella model app.
Yep, I think so.
So yeah, we download the weather data from the Bureau of Meteorology data subscription at regular intervals, and we integrate that. So what actually happens there is every day, like the Bureau updates their data subscription service with a grid of all of the like point temperature data, like for the entirety of Australia at a 0.01 latitude, longitude. So what we do is we download those like as soon as they're available. So we actually poll their server every 2 hours to see if there's anything new to add. And then on our end, it's actually a netcdf file that we basically just append rasters to. Append if it's new data, or if they've, like what the Bureau tends to do, frustratingly, is updates previous rasters, like if they've got like missing data they can impute or things like that. So we've got code that actually like updates the netcdf by appending new ones or going back through and updating the old ones, like in the stack of weather data rasters. And it's a 5 gigabyte file, so it's huge. But even the appending and going through and doing that only takes like a couple of seconds.
And Sam Rogers just wanted to add what the email address is for anyone interested in workshops. So to contact Biometry Hub, it's just biometryhub, all one word, at adelaide.edu.au if anybody wants to contact you guys.
Thanks, Sam.
And I think that's it for our questions. So once again, I'd like to thank Russell very much for presenting a really interesting talk and lots of good information for all our researchers at the Wake campus. So thank you once again, Russell.
No worries.
Thank you, everybody.
Thank you.
Thanks.